we would normally solve a quadratic equation like this by either factoring or with a quadratic equation. But if I wanted to do a graphical solution, that would usually involve graphing y equals x squared minus 6x plus 8 and seeing what its x-intercepts are. Well, its y-intercept is 0, 8. But if you try to find the x-intercepts, what you find is that you end up with the same equation again. And nowadays we would do this by factoring and find out that x equals 4, x equals 2 are the two solutions. And then we would graph it and locate the two x-intercepts, which are at x equals 2 and x equals 4. But if you don't know how to solve this equation to begin with, you're not going to be able to create the parabola, because one of the steps in creating the parabola was solving that equation. So I want to show you how Descartes worked out this equation, x squared minus 6x plus 8 equals 0, without having to make a parabola. And the way it works is you make a horizontal line at y equals square root of c, in this case square root of 8. Should mention, this is for things of this form, x squared minus bx plus c equals 0. There are other ways to do it for other equations, but for this video I'll just concentrate on this type. Now we're going to make a circle, and that circle is going to have as its center 0, negative b over 2, comma 0, which in this case is 3, comma 0. And its radius is also going to be negative b over 2, so I'm going to go, which is 3. So I end up with a circle there. With this circle is always going to end up going through 0, 0. And then the x-coordinates of these 2 points are going to be our answers. And in this case, they end up being at this point is 2, comma radical 8 and 4, comma radical 8. And the two answers are 2 and 4. Now the reason why this works, if you went the other way, if I said where does y equals square root of 8 intersect with the circle x minus 3 squared plus y squared equals 3 squared, if you wanted to solve the system of equations, you would replace this y with the square root of 8, and you would get, and I'll multiply this out, x squared minus 6x plus 9 plus root 8 squared equals 9. And look what happens, the 9's cancel out, the root 8 squared becomes 8, and we do end up with our original equation, which is why this system of equations will solve, or this system of equations will lead to this quadratic equation. Now, more complicated equations require more complicated curves, and I'm going to show you how to do a special type of fourth degree equation, namely x to the fourth minus 13x squared plus 4x plus 17 equals 0. This is called a depressed quartic if it has no x cubed term. The process is we're going to intersect two curves, and one of the curves is going to be y equals x squared. We're just going to choose that one. We could choose any. There are other curves we could choose, but this is the easiest one. Now I come over to this equation, and I replace the x to the fourth with y squared, because if y equals x squared equals x to the fourth. This 13x squared I rewrite as plus x squared minus 14x squared. So you always write plus x squared, and then you kind of think, what do I need to do to that to get back to the minus 13x squared? Copy plus 4x plus 17 equals 0. Now, replace not this x squared, but the other one with a y. That's because of this, y equals x squared. And now move the 17 over to the right side, group the x squared and 4x together, leave a little space there, y squared minus 14y. And now we complete the square by adding 4, that's half of 4, which is 2 squared is 4, so add it to the other side also. here, half of negative 14 is negative 7 squared is plus 49. This becomes 36 on the right-hand side. This becomes x plus 2 squared plus y minus 7 squared. This circle intersected with this parabola will get me my solutions. So here's a nice y equals x squared. Now my center is going to be at negative 2, 7, which is over here. There's my center. My radius is going to be 6. So I go 2, 4, 6 to the right. Go up to 13. Go here, I'm at negative 2, so I head over to negative 8. And I'm here at 7. I go down to 1. Now, I make the best circle I can. If I have a compass, this would be even better. But notice how this circle intersected the parabola at 4 points. Well, the x-coordinate of these 4 points will be the 4 real answers. Sometimes it doesn't intersect at 4 points. If it only intersects at 2 points, there are only 2 real answers. We can see that we get our 4 answers, which in this case are about x equals negative 3.5 approximately. X equals negative 1 approximately. X equals about 1.5. And x equals about 3. So this comes from here. This one is from here. This one is from here. This is from here. So this is a clever way invented by the great Descartes of solving depressed quartic equations by intersecting a nice circle with a parabola. It means you have to have a nice parabola, and you can make a circle with a compass.